Hi there, my name's Orion, and this is my final project for class. The data structure that I chose to do my project on is called a rapidly exploring random tree. A rapidly exploring random tree lets you take a space, let's say this white rectangle here. It selects, let's say you have a start point here and an end point there. A rapidly exploring random tree basically searches that space outward and outward and outward and finds a route from the start to the finish. And I love these little things. Let me show you what I got. All right, so you open my program. Note that it won't run unless you run it out of the same folder as this little file called colors.txt. Colors.txt is a list of every single color in the XKCD family of colors within Python. Personally, I just kind of love that color set, and I use it for all sorts of things. I like it more than the base colors that come with Python. I'm pretty sure I have to download that. I'm pretty sure it comes with standard Python. All right, let's give this little program a shot. Run. So first off, let's choose our playing field. I'm going to go with a rectangular one. It's going to ask us what color we should choose. Let's do one that's white. Cool. I accept that playing field. Yes. Let's add some obstacles. Let's make them, how about blue? Let's add in a bunch to make this kind of challenging and interesting for the little random tree. So you'll note that we're adding the obstacles before adding the start and finish. I think it's a little more fun and dynamic that way. That looks pretty tough, so let's go for it. Next, we need to have a start and an end. That'll do us just fine. Note that it's going to go from the little one to the large one. I'm going to select Y to accept. As regards building the little exploration tree, let's pick a color. How about brown? And it offers you a little demo of the kinds of colors that'll appear. Those seem fine, and now it's going to start going. So the way this works is it picks a random location, let's say here. It looks through all the nodes currently in the tree, and it selects the closest one, and then it extends out this same set distance d towards this. It will stop and try this all over again if it hits an obstacle along the way, and you'll see what I mean. So it's always moving that set distance d unless it chooses a point very close to a previous node, in which case it walks less than that length d. And note that it's exploring, and it's trying to get to the little red circle in the bottom. And there's a good deal of, as the name says, randomness, so sometimes it's quick, sometimes it's slow. Let's see what this one has for us today. Da-da-da. You can fast forward this if you need to. We are one move away from it, and sometimes it can take very brief amounts of time, and sometimes it can be a bit of a journey to get to that last spot. Let's go. There it is. So it prints out we did it, and then finally the very last thing it does is it traces a path from the start to the finish. That's really the goal of the rapidly exploring tree. And yeah, that's my little program. Let's run it one more time and be a little more artsy with the color selections. This time let's do a circular path. Pick a color. Let's try light green. No, let's do something more interesting. How about apple? Is there any color called apple? Yep, there's 3 of them apparently, sure. No matter what word you type in, it's looking through the whole colors.txt list and finding all of the colors that contain that string. So I kind of presumed there might be one called apple. That color, that playing field will do us just fine. For obstacles, let's go with dark blue. And personally, I love running this program over and over and over, choosing different colors each time. It's just, I don't know, I find it entertaining. And you can see that they're not all blue, but they're the ones that have dark blue in the name. So maybe this one's dark green blue or something. One more. Boom. Okay. That'll do us fine. For a starting point and an end, let's go with, I don't know, how about white will do, sure. That's a little boring. I think we could do something more interesting than that. Yep, that was incorrect. Oof. All right. You might need a little patience to wait for this one, but let's really test. Rapidly exploring random tree. Can it actually explore from the start to the end? Let's give this a shot. I accept. For colors along the way, let's make them red. And let's do this thing. See what happens. Again, I'm kind of addicted to watching this little thing. because it's going to have to find its way all. Ooh, wow, I am always impressed by how quick this little thing is. What's interesting is that when there's a lot more obstacles, it's actually quicker because it so often picks directions that it can't go in. So we are waiting for it to choose a point right about there. So this could be a little while. Oh, yeah. Feel free to fast forward. Cruising along, cruising along. Yeah, it's making some progress. It's getting there, slowly. I might have been a little overambitious with this. Oh, it's getting there. Woo, look at that. And we are out and to the left. We're going places. Wow, holy crud, it made it. Ready? And then the path has been found. Boom, there it is. Rapidly exploring random trees. And I really, really, really enjoy these little things. So, a very interesting fact is that this is a fairly good way of finding your way around in any higher than one-dimensional space, meaning this works just as well, if not perhaps better on some level, because it starts to be harder for a human being to find nice, simple algorithms to do this stuff in, especially if you're in like five-dimensional space. I don't off the top of my head know how I would actually find my way around obstacles in five-dimensional space. And so this little thing works just as well. You pick an n-dimensional space and it's got you covered. I love these little things, and I truly had a lot of fun with this project. And you can type in all kinds of interesting colors. Let's do one more just for kicks. And if you're ever in the same program, this is just main function, so feel free to type in just main. Let's do a circular one again. Let's do a background color of gray. That'll do. Let's do obstacles are going to be egg colored. Ooh, sorry. So it will accept it as yes anytime you type in anything that's not an N. So sadly I typed in the wrong thing, but it worked just fine. Let's type in egg. These are all colors that are sort of off. Egg. I don't know why that purple one is called egg something, but I'm sure if I looked it up, I'd be humored. And one more. Boom. Let's do one more. Okay. Let's type in something exotic like dust colored. Nah, those are terrible. Let's redo those. One more time. Nope. Yeah. That last one might be tricky for the program because it's half covered. Let's just, I'm easy going. Let's choose this. And then while we're building, let's go with green. And here we go again. The hardest part of this program, ooh, wow, that was quick. Boom, path found. So the hardest part of this program for me to program was first off testing for has a line touched anywhere along its course? Has it touched the inside of a rectangle or a circle? I came up with a few ways of doing that mathematically. Ultimately, I ended up just within, for instance, this line here. I ended up having it generate 100 small points and test all of them to see if it's in an obstacle. You could also actually mathematically solve, does the line enter the circle? And I had an alternative version that did that. I just kind of liked this one better. It ran smoother, I guess you could say. Yeah, some little bits of debugging, but otherwise, for the most part, everything went smoothly. And I did have to learn some new programming tactics and the small things within Matplotlib. But I loved it. It was a lot of fun, and I'll definitely always remember this funny little mathematical data structure. I love them. Rapidly exploring random trees. There's my project. I hope you enjoy.